A lot of what we do in stats is estimation. So one of the methods that we use for estimation are going to be confidence interval. And the idea is that we might not necessarily know what the population mean is, but we can estimate an interval around it. So we're able to say, well, we don't really know what the population mean is. And it could be because we just cannot collect data from the whole population. It could be something like blood cells, like we cannot take the full blood from a person. That would not be possible. It could be a situation where we just do not have access to the population, but we can estimate an interval around it. So we can say, well, the population mean is between this value and this other value. So here I have this applet, and I have the link in our notes if you want to play with it. So here I'm going to ask for a 95% confidence interval. So the most popular ones are going to be 90, 95, and 99. I've noticed that statistical software tends to default to 95, but we could change this if we wanted to. And remember, there's a relationship between the confidence level and the alpha. So if I want to get the alpha for 95, I would do 1 minus 0.95, and I would get an alpha at 0.05. So there's a relationship between the confidence level and the significance level, which is what alpha is. Here for my example, I chose a large sample size of 100, just because larger samples will be a little bit more precise. And I'm going to draw a confidence interval. I'm going to get one sample of 100 and draw the confidence interval here. So here's my sample, and this little line here with the little dot is my confidence interval. So this green line represents the population mean, which I do not know what it is. But when I calculated my interval, you can see it actually contains that population mean. And I can do this for different samples. And it seems like it keeps capturing that population mean because that green line is still within that interval. Let's do 25 samples of 100 and see how many times we're able to capture that population mean. Wow, so here the red ones, those are the confidence intervals where I did not capture that population mean. So ideally, because we chose a 95% confidence level, not 5% of the time we would not find, we would not be able to capture the population mean. It actually, here I got a percentage hit of 89, which is pretty close. Let's keep increasing our samples and see what happens to that. Yeah, you see I only have one confidence interval that did not capture that population mean. Let's keep going. Ooh, let's keep going. Let's keep going. Yeah, so as I keep increasing, I don't have that many missing confidence intervals that are not capturing that population mean. There's also a caveat whether if you decide to be more confident, let's say 99%, your interval is going to be wider. So of course it's going to capture that population mean. Whereas if you go for a 90%, it's not going to be as wide, but it's not going to be as precise as well, because it's like 10% of the time you could not be capturing that population.